Okay, question 4. Find all positive integers n such that n times 2 to the power of n plus 1 is square. Okay. So if we're adding 1 to something and we get a square, this looks to me like we probably want to use difference of 2 squares. So we have n times 2 to the n equals, we want another letter, let's say a squared minus 1. Okay. So then we can factorize this and we get a plus 1 times a minus 1. Okay. Now, because a plus 1 and a minus 1 have a difference of 2, that means that they cannot both be divisible by 4, right? So because we have this large power of 2 dividing their product, 2 to the n, that means, well, firstly, they're either both even or both odd, so they must both be even, or else 2 to the n never divide them. Yeah, because n is a positive integer. So n is not 0, so therefore n times 2 to the n is even, and so a plus 1 and a minus 1 are both even. However, they cannot both be divisible by 4, so we'll put one of them is divisible by 2 and not by 4. So then what does the other one have to be divisible by if one of them is divisible by 2 and not by 4? Well, in order to be divisible by 2 to the n, the other one of these two factors is going to have to be divisible by 2 to the n minus 1. Right? So now, sort of looking at this, we should be able to see that if you take a large n, this isn't going to work because 2 to the power of n minus 1 will be significantly greater than the square root of n times 2 to the n for sufficiently large n. Let's say, in particular, if we take n at least 4, then that means 2n, hang on, maybe we need to go a bit bigger than 4. Let's say 5. That means certainly 2 to the n will be less than 2 to the power of n minus 1 minus 2. Right? We can just check that this is true for n equal to 5, and then because the right-hand side grows much more quickly than the left-hand side, this will be true for all n that are at least 5 as well. So if n is at least 5, then this inequality holds. And that makes things go wrong because if one of these two things is divisible by 2 to the n minus 1, that tells us it has to be more than 2 greater than the other one. So that means n is at most 4. So then we only need to check n from 1 up to 4. So n equals 1. So hang on, let's make a table. So n, and then n times 2 to the n plus 1. So for n equals 1, n times 2 to the n is 2 plus 1 equals 3. For n equals 2, n times 2 to the n equals 8 plus 1 equals 9. For n equals 3, n times 2 to the n is 24 plus 1 is 25. And for n equals 4, we can just about squeeze that in also. N times 2 to the n, that's 4 times 16, which is 64, and then add 1 for 65, right? So we can have a look at this and see which are square. Well, 3 isn't square, 65 isn't square, but 9 and 25 are both square. So the solution to this problem is n equals 2 or 3.